In doing DE by substitution, the first step you need to do is to differentiate the given substitution. Like in this case, the suggestion is to let y be 1 over z. So you differentiate this one, you get dy dx equals to, let's say from Zoe, if you differentiate the y, what would you get? Minus 1 over, is it correct? dy dx. dy dx. We want dy dx, is it? We want dy dx. Is that all? Right. It's something like doing it implicitly, let me write this x carefully. Right. So if you differentiate the given substitution, you will get this. So now sub this, substitute into dE. You get minus 1 over z square dz dx minus 1 over x z equals to 2. Right. So after you have differentiated the given substitution, you will plug it into the dE, and then you get this line. And then I'm going to tie up this line to become dz dx plus okay, Arohi, if you read my mind, what do I have on the right hand side? Okay, it's all in your mind. Now I see it, and now you don't counting. What did I do, Arohi? What did I do? Very good. Times negative c squared. Right. Then once you arrive at this line, you will realize that this equation has a name. Alice, what is the name of this equation? It's called the first order linear DE. Right, first order linear DE. And then if you see this as the first order linear DE, there is already a known method to solving this. Right now. So firstly, what do? You find the integrating factor. You can wash yourself up. You can get just go wash it. Let's go wash it. So I find my IF the usual way, e to the integration of that thingy. Okay. In the other class, I asked them, why does this become this? You know why? Brilliant. Right, it's e power log x. And then e power log x is just x. Okay. Yeah, I know that the challenge is this, no. Okay, two cases, right? If x is negative, if x is, okay, let me erase this and write it. If x is, sorry, long. Okay. Okay. Okay, let's see what happens again. If x is positive, this is going to be e ln of x, and it's indeed x right now. So if x is negative, you're going to say that this becomes e ln of negative x right now, and then you're going to say this like right now. Okay. So therefore, you're saying that there ought to be two possibilities. You know what I mean? But let's assume that we just choose to be just x. It's okay, you know. It may look illegal. It may look illegal. It's alright, you know. Right? Just to assure you that no. We're not brushing off. No, we're not brushing off. We are just saying that maybe we do it first. And I give you the rationale later on, okay? I'll give you the rationale later on. So you just do it first as just x. Take it as just x first. Alright? Then the next line is, if this is if, right? If this is if, this becomes y times if is equals to integration of minus 2x dx. Yes. Oops. You're right. Z. Thank you. Okay. Z times x. So zx is equals to minus x squared plus c. And then your z is actually 1 over y. So therefore your y is equals to x over okay. Now let us see how we actually reconcile with what we had earlier on as raised by all of you. You say, how can we just simply sweep the thing underneath the carpet and assume there's nothing happening? What I can do is, after getting the solution, right? After getting the solution, you just need to verify that this indeed is a solution, that it works. You can just verify. You are not wrong to say that Mr. Lim has over relaxed the calculation and simply just take only this one. So by using this one, right, you obtain a solution that is like this, and I want to verify that this solution works. What I want to do to show that it works, I just differentiate into the differentiate once and put on the left hand side. So let me put on the left hand side again. If you differentiate the y, you get v du dx minus u. Okay, you get this line over v squared. Then minus y over x. You didn't see the square, right? I will write down for you. You see the square? Okay. Then let's combine them as a single fraction. On the denominator, right? On the numerator, you'll be just left with 2x squared. Do you believe me? And this is indeed a 2y squared equals to the right side. So actually it works. So how should you view this thing though? You just view this thing about the IF as just a very not so refined method to make things work. Then after the thing works very well, you can justify that everything all fall in place by verifying that the solution does indeed satisfy the DE. You know what I mean? So that will ease off your discomfort, about just taking a E ln x as just E ln of modulus x, right, as just x. Supposedly, if we have used minus x, will it work? Supposedly, we say, hey, we intend to solve this DE using minus x as my IF. Let's see if it works. Okay, let's see. Okay, let's try. If we were to use minus x, right, this gives you supposedly use IF equals to minus x. Okay. Earlier on, I have used x, right, and that caused a bit of discomfort. I hear from the class in front, But now supposedly we use minus x. Let's see what happens. Will it work? Okay, let's see. So I times by minus x to the given DE. Minus z. Sorry, okay. Okay, yeah, I times minus x dz dx minus z equals to 2x. Okay. On the left hand side, right? On the left hand side, this becomes on the left hand side, right? On the left hand side, what do you get? I times that by minus 1 over x. I get dz dx plus 1 over x z. I get back the same thing. I'll still get back the same thing. So therefore, whether you use x or use minus x, right, eventually it will add up to be the same thing. Right? So for the reason, conveniently, I have taken the easier option, and after getting a solution, if you wish to, you can verify. But if you want to just accept this and believe by faith, nothing stops you from just concluding here. So I find that actually sometimes solving DE, it causes a little bit of discomfort because we are like doing a little bit of illegal stuff, and just to get to the answer first. This is what you sometimes do, is it? Sometimes if a math problem, right, we come up with the wrong way or the intelligent way to get things through, and after that we verify that this way of thinking get you a correct solution too. Okay? If I can be so clever, I see a DE, I come up with a suggested solution just by looking at DE, and then I prove that this solution works. I'm damn good, really good, And sometimes it's a case for solving DE, because sometimes you, in the course of doing a experiment, you come up with a DE that's very complicated. It's none of the standard ones that I've seen. But you're so clever, that looking at DE and figuring out in your mind, you came up with a function that works. You hit a jackpot, And that's the case actually in the case of solving D at high level, actually sometimes they just guess the answer first. No? They made the first guess, didn't work, then they tweak until it works. That's how it happens in the real life, you know. Yeah. Right. So, but if the standard DEs, of course, then there are known methods to solving them. You can just use them. Okay. So in this case, actually, this is considered a standard DE. So we use the standard way to doing it. We are guaranteed to be correct. And admit that we may do something that's quite illegal along the way. In the other class, they asked me, you know, how come this line comes about? How does this line come about? Okay, let me help you to see what's going on again. In step one, I find the IF. I'm saying to you that after getting IF, you can straightly write down step 2, the function, whether it's z or y, times the IF, and then the right hand side, integration of this and this and this. In short, I'm saying this to you, no? In short, I'm saying this to you. I'm saying to you like this, no? I'm saying that if you got a DE that is like that, in short, I'm saying this to you. I say step 1, find the IF, which is E integral of px dx. Step 2, I'm saying to you, once you get IF, I'm saying that you can skip some details and right away and the step 2, right, is a big jump, you know. But because the step in between step 1 to step 2 is quite standard, personally, I don't bother write down. I'll just jump to step 2. And in the other class, they questioned me, you know, which part of the notes actually allows you to jump to step 2, you know, or how step 2 comes about rather. Actually, it's written somewhere in the notes, but I realized that it's not that explicit, you know. So I intend to now show you explicitly how step 2 comes about. Okay? So after you have found the IF, the idea here is you want to multiply throughout by the IF. So this E integration of E to the power this thingy dy dx plus E integral of px then y equals to E. The notes doesn't present this way. The note doesn't present like this, but I'm going to show you like this. So after getting IF, what we do is we multiply throughout by the IF. In so doing, you find that the left hand side now becomes a z. The left hand side becomes the differentiation of something. Okay, let's hear from Alexis. What is the thing inside this bracket? And now you want to give yourself the 30 seconds to verify that it is true. Okay, why is that so, right? Why is this true, right? Analysis, for other people, I'll give 30 seconds. For you, I'll give 25 seconds. In 25 seconds, analysis want to see that this to this is true. Your 25 seconds starts now. You're right, analysis, you're right. And then? No need, because the differentiation of an integral is just the integral itself. You're right, like, you know? Yeah. Because the yellow law that you know of requires a limit. You know what I mean? So it's just a product rule differentiation. So once again, do you see the last blue line? How the second last red line leads to the last blue line. If you do agree, then you will get that statement that I wrote down earlier, that the function times the IF is equals to the IF, the integral of the IF times QX. And this is the green set statement that I was trying to advocate, that once you got IF, you immediately take Y times the IF equals to this thinking. Understand? So that's why you realize that whenever I come across first order linear DE, step 1, I calculate the IF. And step 2, I will go immediately to the green line. The in-between is always a standard process. No? So I will do only this and then straight away this line. This is what I always do. So in the other class, they wanted to see a reason why it's like that. The notes has it, just that it's not so explicit, I was trying to refer to notes earlier on in the other class, I realized that it's not that explicit. It's all textbook, it's all documented in textbooks, standard textbook that you can find. It's nice to turn on the siren, and then everyone give way to you. The good old days at the policeman, when they drive a police car on the road, right? Everyone just give way to us. Very nice feeling. Yeah. I got my driving license in the police force. My training vehicle is a police vehicle. Yeah. Very easy to pass on, because everybody will give way to you. Okay, so that brings us back to this picture, wherein I demonstrated to you that this line, that I take the function times the IF. So I hope that this discussion also eliminates the fear in you whether you ought to be using minus x or to use x. It'll be the same. It'll be the same. So for a reason, in finding the IF, right, we kind of relax the requirement. We don't even put modulus. And we don't even put plus c in the integration. You realize that we don't put a plus c. If you're that clever and you look at the DE and without doing much calculation, you can spot on the IF, right? You're good. You're good. Right? If you can bypass it and straight spot on the IF and straight do it, Right? Okay, so this much about substitution, and we are now into this section of the notes. It's okay? Any question about the earlier example? Do you still need to see more of the earlier example? And lo and behold, we are moving into section 4.7. Technically, this is the last section of the notes. Technically, because there's a second order behind, but I don't think we'll be testing you in the school exams, I think, and definitely not in the AP exam, definitely not, right? So 4.7 technically is our last section. After 4.7, right, I intend to do tutorial, which I believe you have done it, the 4.1, right? A lot of people got a wrong idea. SIL represents what? It's called staff initiated learning. Staff initiated. Did you know? The Thursday one was student initiated learning, is true. But the Friday one became a capital S. Thursday was student initiated learning, it's a small letter S. The Friday one, there's a big letter S. You didn't see a difference. Hold on. Okay, are we ready to go, right? Yeah, enjoy yourself. And then, are you in white socks? May I ask? Are you in white socks?
Yes.
Okay, can't see the socks. No? Enjoy yourself. They're very nice people, no, really. they're hosting the Mahido school students. No? I've been to Mahido. They only have 3 years. Your equivalent of year 4, 5, and 6. The people there are very well behaved. Just like all of you here. Yeah. They greet me even though I was a total stranger there. They will approach me and then talk, they're very nice. Okay, let's press on to this last part of the so-called notes. I am sure some of you have browsed through. Technically, in this section of notes, it is about this equation. Okay, this equation is given a name now. It's called the logistic model, also called the logistic growth model. This model is more realistic than the exponential model that we learned before. As you already know by now, right? The exponential growth model, say you keep going up in the value keep going up. The icon is turned on, is it? It's not yet 11, 11:01 already, but it's not on yet. So I think just look inward. Okay, you know that in many physical phenomena, it's not always just keep increasing. There's always the other factor, the decrement part. Just like population growth, our growth doesn't keep, our population doesn't keep growing up, because there's also the death rate, there's also people leave the country and so forth. So there's always the decremental factor. So in this case of a logistic model, it is actually more realistic because it has also the decrement factor in it. So this chapter introduces to you, or this section of notes introduces to you this other DE called the logistic growth model. And our aim now, is to show, or rather to solve this DE. I want you to note that in this DE, right, K is a constant. Constant of, what's the word? Proportionality. This letter L also represents another constant. This constant in this chapter has a name. It's called the, what do you say again? Carrying. Okay, it's a term where you will realize later on a term where the y will approach when t goes very large. You will see it soon, right? And this L is called the carrying capacity. So given a D of this nature, we are going to learn how we can actually solve this DE. You have to memorize that the DE looks like this. How does it look like? It looks like this. dy, it looks like this. Dy dt equals to k L minus y. What's the name of this DE? It's called the logistic model. And we are going to solve this DE. Obviously, you will see that this DE is actually the variable separable DE. And to solve this DE, Jianpeng, what do? As the name suggests, you have to separate them into two parts. Okay? I have simply separated them in two parts. Because it's a variable separable equation. And now I'm going to do something, are you ready? I'm going to do something about it. I'm going to do this. Make no mistake, I've introduced something on the left and likewise the same thing on the right. I have placed the letter L both on the left and on the right. Who can read my mind why I want to do depth. Hyla, why would you think I do that? What's his name? Oh, 阅兵 right? 阅兵 it says 你不舒服啊？I mean, how is it? Okay.
You live in Yale, right?
I beg pardon?
You live in you have a house.
Convert is it?
No, Yale.
I live in KL.
Yeah.
No?
Oh.
Not because I live in KL. I have a house in JB, but not KL.
KL.
Why do you put an L on both sides? Chen Yan. Why do you think I put L on both sides? Can you read my mind?
So that you call KL.
So that it becomes handy. That this thing becomes like that. Can you see this? It comes in just handy. I broke it down into partial fractions. So Yue would it be better off I let you take the GT3 now so that you can go and rest later? Do you prefer that way?
Yeah.
Okay. As I march to my desk to get the thing for him, could y'all actually, who couldn't get this integration correct? Anybody has problem with this integration? All got it? Okay. Let me write nicely. Okay. This is long. Okay. Let me write nicely. Okay. You have to get to this line by using the simple integration formula followed by the logarithms law. And then once you reach this line, are you able to actually obtain this as well? Hey, there's a plus C. Right. There's a plus C. Oops. And then it becomes this line. Okay. And then right. You want to make y the subject by making y the subject. Okay. Give yourself that 30 seconds to fill this next jump. 30 seconds.
Well, that's true.
Okay, a show of hands up. Who need me to elaborate the dot? You got it? Okay. Who needs the elaboration for this step here? Anybody needs? It's simply to cross multiply and everything that involves y, you move to the left. Yeah. Just like changing the subject, changing the subject. This skill of making something the subject, right? You master it in year 1, right? Or year 2, Yeah. And you thought that it's the end of the story. It's not, For this question, I got in one more information. That when t is equals to 0, y is equals to y naught. Typically, it is written as like that. Typically written as like this. Now you want to find a, you want to find a constant a in terms of whatever that you have there. Okay, so I'm going to continue here. No? I'm going to continue here. Okay, continue here. So you put t as 0 and y as y naught, and then you will get your a to be equals to, I will just expect you to do up the arithmetic. No, it become what, y naught divided by L minus y naught. You check whether or not it's true. You put in t as 0, y is y naught, and you make a the subject. And see if whether or not you truly get what I have there. But here you got it, yeah?
Yes.
You try it.
Yes, I tried a different method.
Okay. So from here, right, you thought it's the end, it's not yet, no, it's not the end. What you're going to do is, you're going to do it, okay? Rather, we are going to do it. We're going to do it, you know. So after getting the A, I simply plug it in. Yes.
Are we allowed to use definite row instead of LC?
Are we able to use,
Like in the exam, are we able to use definite row?
like the fixed students are like, yeah, sure. Yeah. And then finally, you get this line, no? You need to actually fill the gaps, no? You get this final line. You have to fill in the gaps. Yeah, you can see. Okay. You realize that it's very much just arithmetic. You know. If you ask me, where's the D component? No, the D component is only here. This is actually the D component. No. The rest of them is just algebra. If you can obtain up to this line, and you can't bring yourself through to the last line, right? It's actually a calculation. You can do it slowly. You know, I'm sure, you know, if you're exercise a bit of care, you will be able to get to the green line. Right. So what's happening here is, what I've done is, I'm telling you that from this given DE, right? You go through the solution that I just shown to you, and you will be able to obtain this solution. Right? So this DE, and then this is the solution. So far, there has never been a test question or exam questions, whether in school or in AP exam, that they ask you to prove it. That is why you realize that this notes, right? I don't remember them putting it in the notes, the proof. Is it the notes? The proof is in the notes. Don't have it. Which means you want to memorize, no? Not just the solution, you also memorize the equation, you know. Because you must remember that the equation look like this, so that you can actually abstract the correct value for L. L has a name. Aiden, what is L called? Okay, I give 3 choices, don't turn the book, I give 3 choices, MCQ, okay? Is it called carrying capacity, or carrying capacitor, or carrying charges? Carrying capacity, carrying capacitor, carrying charges. Capacity, you're right. Okay, you're busy with something else, Aiden, I'm sure. Are you busy with? Are you busy with something else? Are you doing math or something else? Okay. So let's test out. Aiden, without looking into the notes now, what's the solution to this DE? Y naught times L, Y naught times L, holding over L minus Y naught e power minus KLT plus Y naught. You have to just memorize it, no? You write in your palm and you go to the examination hall, you're doomed. It's cheating, right? You see how I derive it, right? Yeah, it's quite, it takes about 2 minutes. And then you're also not so sure, you get scared, you get worried. So I would think that the wiser choice is to learn it like just pure memory work. You must remember that dE looks like dy dx equals to k, open bracket L minus y times y. You need to remember that the solution is y equals to y naught times L over L minus y naught e to the power minus KLT plus y naught. The other class told me they decided, the moment you walk to the examination hall, they just write down the formula in the booklet itself. That's the safest, because the booklet is only obtainable when inside the hall, so they can't say that you bring it in, right? The solution or the other. Okay, on this page here, you have the beginning, the equation, you have the end, the solution. There are actually 5 pointers here about this equation and its solution. I wonder if there's someone among you here who can march forward to the board, address the class, and explain to the class bullet point number 5. In their class, Viresh did it accurately, very accurately, hit the jackpot. Viresh, y'all know Viresh, right? I'm sure. Okay, is there someone who is able to march to the board and with one hand address the class? Tell the class why. Okay, that has been Mahil. Okay. Wait, Mahil, wait. Address the class, not just talk to me. You gotta address the class. Make sure the class can see your writing, make sure the class understands you.
So we want to maximize the function to see where it's this is the highest. So you just differentiate again. What dg squared? Oh.
Class, you understand Mahil? You're done. You're done, Lydia.
Thank you.
You go back to rest, is it? Then go back to your bunk to rest.
No, I still have a test later.
Oh, so sad for you. Okay. Gavin, if you need to go and rest so that you get energy to do the next test, just go ahead, Yeah, because you might want to go back to your bunk and then rest, then come back for CS. You're good, He's not wrong, no, just a bit more complicated, but technically you could try to perform a derivative a differentiation, you could. But otherwise, you can try to plot the graph of dy dt against y. And it's simply a quadratic equation, and we all know, everybody knows, that in the case of a quadratic equation, the midway between the two x-intercepts is where you find the max. Oh, thank you, Wen Kai. Right, thank you. Okay, it's right. Class, can you read bullet point number 1? Let's have Kai-Wen to march to the board, march to the class, address the class, and tell us what bullet point number 1 is all about.
If y is much smaller than L, then the logistic group model behaves like an exponential growth model.
Wow! She's right. Yeah. She understands what this means. Right. Much smaller than L. She's right. Okay. For this bullet point number 4, you want to note that these two are possible solutions, and you see them more vividly when we do the next question. Are you ready? There are altogether 5 parts. I'm waiting for a response. There are altogether 5 parts. This question got 5 parts. Do you see the 5th part, everybody? There's actually a part E, that goes like that. It's not written in your notes, no. It went out of print, outside the print. Okay, can you try to draw the solution curve for these 5 scenarios? And to do this kind of question, right, you need to exercise your gut feel. Okay, try to draw it in your book. Yeah, sure. Okay. From school. The doom, The doom. Cannot, no. Cannot. School rules say cannot, no. But the more an MC, it must be away, no.
Oh, never mind, I don't have.
Jianpen, you're in front here not because I want you to distract Tyler, no. You're in front here because I want to watch you more closely, not for you to go and irritate Tyler. Okay, can you draw your graph? And then we compare. By the way, I've emailed you your CA scores. If you don't get full marks, you are the minority, you know. If you don't get full marks, you're the minority. For the GT3. I emailed you, alright? So, okay, Caitlin, don't raise a hand. You can tell me later.
So it's just,
Wrong day.
no, I realized at the last moment I didn't use my PC and I also slowed down.
Okay, it's alright. Okay, I want you to see that the red line is due to C. Red line is a part C. This is the case. This is a case where the solution is the solution y naught equals to L. No? When the y naught is L, your solution, right, is just the entire red line. I also want you to know that the graph is misleading. You know, the red line serves also as an asymptote for the other three curves. It's an asymptote, you know, so mustn't draw them touching. If you magnify this solution many times, you will see that it's not touching, you know. Just like because I diminish it, it looks like it's touching. If I make it very huge, you see it's a asymptote. There is a part E, y naught equals to 0. Where is the part E solution? Let's hear from, okay, green. Where's part E? Y naught equals to 0. Which line is that? Right, the t-axis. When y naught is 0, it's just the t-axis. Right. Now, in the bullet points above, it says something about the starting point. It says again, if your starting value, the y naught, if the y naught is below the L over 2, if I amplify this a bit, class, in this case, I want you to note, 3 is L over 2. Why is it so? Because L in this case is 6. How do I know it's 6? No, the equation says so. Right, based on this is my L, and this is my K. 1/4 is my K, and 6 is my L. So in one of the bullet points above, it says, if you start off below L over 2, there is actually an inflection point. This inflection point represents the point where dy dt is the largest, and this occurs at exactly the point when y is L over 2, which is 3 in this case. Can you see? This point, right, is exactly at this one. So when you start off with a y naught below the L over 2, you will have an inflection point shown on the diagram. If you start off with a point, that is above the L over 2, then your inflection point is actually on the left here. And then come and think about it, this is actually a time axis. Technically, there shouldn't be anything on the left side. Which therefore says, if you start off above L over 2, in this case L over 2 is 3, you won't get any inflection point. You know what I mean? Right. So when that happens, if you really insist, this point is where you achieve the highest gradient. You know what I'm saying? But in most circumstances, when you start off below L over 2, your inflection point, or the point with the highest gradient, occurs at L over 2, when y is L over 2. This is something you want to note, because believe me, it will always ask you to draw the graph. If you're not careful and fail to show the existence of an inflection point, or you shouldn't be showing and you show it, whichever way, okay, you'll be penalized. I want you to realize that when you actually draw it as exam question, class, you should avoid this one, you should avoid drawing the left side because there's no negative time. There's no negative time at all. Right? I personally don't believe that now we can build a time machine to go back into the old days. No, I don't believe. But I do believe that you can potentially build a time machine that go forward in time. That means you can go forward and 1,000 years later you come back, you're still a young looking 键盘 with a nice hairstyle, I believe. Because Einstein theory or special relativity, right? Yeah, near the speed of light. Yeah. So therefore, I don't believe there's a negative timeline. Things that's been passed is already gone and forever buried. Okay, if you start off with why not that's above, like this, right? It will just simply dip towards the asymptote. Whichever case it is, you will find that in all this graph, you will taper towards the carrying capacity. That's why the term carrying capacity is the L. Any question to raise? So this graph is quite useful for me to then tell you about these bullet points. Otherwise, this bullet point can be quite hard to understand. Like pointer number 3, right? If you are starting below, you'll be increasing. If you're starting above, it'll be decreasing. Can you see? Right. So in the long and short, remember the equation, remember the solution. Let's test you out again. What's the solution? Why not L divided by that thing? Just memorize it. Study math like bio. Okay. With this in mind, we can press on, Okay, press on. Okay. When you read this equation and you recognize that it is actually the logistic model, the first thing that you want to do is you want to write down the value of K and the value of L. You know what I'm saying? In this case, Kaiwen, what is your K? Is it 2 or 3? What is the L?
1.
Brilliant. Are you very tired today? You doze in and out now. Maybe when we have lesson, we should turn on K-pop music, no? I should bring a speaker that's a what do you call it? Bluetooth speaker. Then you can play your nice music. Maybe the music will keep you alive.
Yes.
Everybody likes K-pop. Can I assume that? I don't know why, no. I don't understand why my daughter likes K-pop. I can't appreciate it. But I'll pretend I know. Yeah, daddy loves K-pop as well. I'll pretend, just.
Just treat it as a genre like any other.
Okay.
It's just a purpose.
Because sometimes when I listen to it, I say, hey, isn't this English songs? Then she say, K-pop always mixes with English. Yeah. And I ask her, do you understand? She said doesn't, but she just loves the tune. She wants to be a K-pop dancer. Okay, so maybe you should bring a portable speaker, then you can play K-pop music from one of your handphones. Who can be a DJ? Who is like Katisha? Okay. One day you play Chama Chalo on screen. Chama Chalo. There's this very nice MTV, really very nice. Even though I'm not of the culture, I enjoy it, very colorful, very vibrant, and the movement I can't do, Okay, let's come back to math. Okay, let's start with Wen Kai, part A. What do you think? What proportion of population has heard the rumor when it's spreading the fastest? And you will say that it happens at L over 2, remember? At L02, right? We learned just now that at L02, it will have the greatest gradient. And therefore, this is the proportion at y equals to L over 2. Remember just now, Mahil came to the board and gave this equation. I also supplemented with the graph. And we learned that now the gradient is the greatest at L over 2. In this case, it's half. So the proportion is 50%. Half the population has heard the rumor when it is spreading the fastest. Okay, next part of the question asks, at time t equals to 10% heard, find y as a function of t. So for part B, right, if you have already memorized the solution like what Kayet has already done, Kayet, what's the solution? Y equals what? Good. Press on. So what is a L? 1. What's a K? 2. Just plug it in. So what's a Y naught in this case? How much is a Y naught? Y naught in this case is therefore 0.1. L is equals to 1 and K is equals to 2. So if I memorize the solution of the DE, this one is just a giveaway, just plug and play. Nothing stops you from deriving on the spot like what Mahil suggested. If you are confident and you want to derive on the spot, sure, at your own reason. You are encouraged to memorize. Shall we do it together without looking? Shall we recite the solution together? At the count of 3. 1, 2, 3. Y naught times L over L minus Y naught times E to the power minus KLT plus Y naught. Yeah, it's quite mouthful, but the more remember, the better you are. You know that good memory is also a display of talent, There are some people who have very good memory. This is actually a talent, Right? So if you can memorize things and reproduce them letter for letter, right? You're quite talented, And then part C. Okay, if you can do part C, you win it all. You need this. It's just a solution that we had from the part B. You need this. Let's see who can do this question. We'll end on this question again to motivate you a bit. We'll end on this question so that you have an early break. After my lesson is what? Oh. Okay, a longer lunch then, lunch earlier than others, okay? How do you do part C? It looks like Kurtish already knows how. Kurtish, 怎么做? That's nice. How do you do part C?
You put that expression equal to.
Brilliant! Alright. You know this topic very well, is it, Katish? That's why you irritate Mahil. I can see you trying to irritate him, you know. Right, and then solve for t from there. It's just like that. It's that all. That's all I'm counting. Okay, 请问 why you think you put a half? Why did Katish says just equate to half like what I've shown on the screen? Why? Because in the part A, right, we say that rumor spreads fastest when y is half. That's the reason why. Okay? And then from there you solve the equation, you should get an answer, and the answer is this one. According to this thing is ln 3. Okay, the answer is ln 3. You use the same thing that I given to you earlier on, you should get ln 3 as well. You know, in the next lesson, I intend to actually start off, I think by next lesson, you have completed this set of notes. I don't intend to go through second order D yet because I want to be very sure what my colleagues are going to do. You know what I mean? So after this section, 4.7, I intend to do tutorial first. I want to check with my colleagues, what I'm going to do about the last bit. Okay, with this, as promised, we will end the lesson.